So today we're going to look at different ways to solve a systems of equations. So a system of equations is something that looks like this. All right, so we're going to have two equations. Now, we graph two lines and then they intersect each other. The ordered pair of the intersection tells us when, which is the x value, and how, which is the y value, the two situations are related. So let's look at some ways to solve systems. The first way is numerically. So we want to use tables, right? So we're going to plug in x values and find y's, and we're going to look for matching x, y values in our tables. So I have y equals 2x minus 7, y equals negative 4x plus 5. So let's start with the first equation. So plug in 0. That goes away, and I'm left with negative 7. Plug in 1. 2 times 1 is 2, minus 7 is negative 5. 4 minus 7 would give me negative 3. 6 minus 7 would give me negative 1. Now, let's do the same thing, but for the bottom equation. So let's plug in 0 first. That goes away, and I'm left with 5. Plug in 1. So that would be negative 4 plus 5, which would be 1. Negative 8 plus 5 would be negative 3. Negative 12 plus 5 would give me negative 7. Now, when I compare my two tables, I want to look for the same xy. So when I look through both tables, I see that when x is 2, y is negative 3 for both of my equations. So that would be my answer. Now, when I write my answer, I have to make sure I write it as the ordered pair. So my answer would be x equaling 2, y equaling negative 3. Okay, so that's using tables. Now, let's look at how we would solve it graphically. So we're just going to, instead of graphing one line like we've been doing, we're going to graph both lines and look for the intersection, which is where they meet each other. So remember, there's two ways to graph equations, right? Depending on which form they're in. We have slope-intercept, y equals mx plus b. So again, we plot the b value, then do rise over run. And then we have standard form, which we will utilize the cover-up method to make things quicker for us. So looking at my example here, in this example, the equations are both in standard form, right? X and y are on the same side, so I'm going to do cover-up. So for the blue equation, I want to find the x-intercept first. So cover up the y, and I'm left with 4x equals 12. Divide, I get x equals 3, which would be the ordered pair 3, 0. So plotting that, 1, 2, 3. Find the y-intercept, cover up the x, so that leaves me with negative 6y equals 12. Divide the negative 6 off, get y equals negative 2, which would be the ordered pair 0, negative 2. So go down 2 and put my dot. And there is the equation of my first line. Now, to do the purple line, or the bottom equation, right? Same thing, standard form, so I want to do cover-up method. So to find the x-intercept, I cover y, divide the 2, so x would equal 3, which is the ordered pair 3, 0. So I plot that, find the y-intercept, cover up the x, so I have 2y equals 6, divide, which would be the ordered pair 0, 3. So here would be my second line. Now, we're looking for the intersection point where the two lines cross or hit each other, and that would be right here. So my answer for this system would be that ordered pair where they hit, which would be 3, 0. Okay, so that's an example graphically. Now, the last method we're going to look at today, there's still one more that we'll talk about in the next video, but this last one is a little bit more algebra intensive. So we're going to look at substitution. Now, in order to use substitution, okay, my first step is going to be to solve one of the equations for one of its variables, meaning I want to get either x equals or y equals. Okay. So when I look at my example here, right, it looks like this bottom equation would be the easiest to get one of the variables by itself, because if I look, y is already almost by itself. We just need to do one little step to get it by itself. So I would subtract the 3, and then I would get y equals 5x minus 3. So that's step 1, get one of the variables by itself. Now, step 2, I want to plug whatever I found in step 1 into the other equation and then solve for the remaining variable. And remember, we want to use my order of operations, PEMDAS. Okay, so I have what y equals. Y equals 5x minus 3. So I'm going to plug it into the top equation wherever I see a y, which is right here. So we replaced 2y with 2 times what y equals, 5x minus 3. Okay, then I do my order of operations. So we would distribute the 2, and I'll do this over here. So we would have 4x plus 10x minus 6 equals 8. Combining the 4x and the 10x, right? Combine my like terms. I get 14x minus 6 equals 8. Add the 6 over. 14x equals 14. And then I divide. 14 divided by 14 leaves me with x equals 1. Okay, now, step 3 is really the final step. Once I have one of my answers, so I have x equals 1, right? Now I'm going to plug that value that I found in step 2 into an original equation. Okay, it's very important you go back to the beginning of the problem and pick one of the original equations. And then once I plug it in, I'm just going to solve. Okay, so looking back here, I'm going to pick the same equation. It doesn't matter which one you pick. This one just looks a little bit easier to use. So I plugged the 1 in for x. So my original equation was y plus 3 equals 5x. I'm replacing x with 1, which I did here, right? So that gives me y plus 3 equals 5 minus the 3 over. I get y equals 2. Okay, so my answer would be the ordered pair 1, 2. Now, you can go through and check. Okay, so we want to check the solution, which is an ordered pair. And this is just to double check that you got the right solution. You didn't make any algebra errors. So you just plug the point into both equations, and if they give you the same answer, then on both sides, then you're good, right? So plugging in x equals 1, y equals 2, 4 times 1 would be 4, 2 times 2 is 4, which would equal 8. So that one's good. Plugging into the bottom equation, y is 2, x is 1. So 2 plus 3 would be 5. 5 times 1 is 5. So both of these are correct. So my answer is true. Now, if you're confident in yourself, when you find your ordered pair, you don't have to technically do this last step. It's just good practice to make sure you got it correct. So let's look at one example where we have to do kind of all this without breaking it down like that problem was. So it says to solve by substitution. So meaning I need to get x equals or y equals. In this problem, it looks like this bottom equation will be the easiest to make y equals. So to do that, I would subtract the 4, and I get y equals 3x minus 4. Now that I have what y equals, I want to go to the top equation and find my y. It's right here. So I'm going to take what y equals, and I'm going to plug it in wherever I see a y. So I'll try and color coordinate this. I'll do the top original stuff in purple. So we have the 2, and now instead of y, I'm replacing y with 3x minus 4. And the rest of the top equation is plus 6x equals 12. So distribute the 2, and I get 6x minus 8 plus 6x equals 12. Combining like terms, I get 12x minus 8 equals 12. Add the 8 over. Ooh, this one's going to give us some fractions. 12x equals 20, and then I divide. So I get x equals 20 over 12. But I need to simplify. So 20 and 12 are both divisible by 4. So x would equal 5 over 3. Now, I want to plug in to one of the original equations, and I'm dividing by 3 on my x, right? It's 5 divided by 3, 5/3. So it looks like the bottom equation might be the easiest here, because I'm multiplying by 3, so it'll get rid of my fraction. So let's plug in 5/3 into my x of the bottom equation. So that would look like this. Y plus 4 equals 3 times 5 over 3. The 3 times the 5/3, the 3's would cancel. So I would have y plus 4 equals 5. And then I just have to subtract. So y would equal 1. Now remember, final answer has to be the ordered pair. So my answer, 5/3, 1.